It's time for a new section of this course called Objects and Functions. In a lot of JavaScript courses, they treat these two concepts as two different subjects to teach. I think that's a big mistake, because while in other programming languages, objects and functions are two distinct things to talk about, in JavaScript, they're very, very much related. They're really, in many ways, the same subject. So let's talk about objects and functions. The first subject, or the first topic we'll discuss, is objects and the dot. Remember, we've already said that objects are collections of name-value pairs, and those values can then be other collections of name-value pairs. But for our purposes now, let's look at objects from a little bit of a different perspective. Let's think about how an object lives or resides in your computer's memory. An object, like we said, is a collection of values that are given names. But what values are we talking about? Well, an object can have properties and methods. So an object can have a primitive sitting off of it, and that would be called a property. Remember those primitive types that we talked about. So any one of those, like a Boolean or a number or a string. An object could have another object connected to it as a child, so to speak. And this is also considered a property. Remember we said the value could be another name-value pair collection, or that is, another object. An object can also contain functions, and in those cases, the function is called a method when it's sitting on the object. So it's still a function, but it's connected to an object, and so it's called a method. So objects have properties and methods, and these sit in memory. So the kind of core object will have some sort of address in your computer's memory, and it will have references to these different properties and methods which are also sitting in your computer's memory. Now, they may be related to the address of that base object concept, or they may not, but either way, the object has references to the addresses or the space or the spots where these different properties and methods live, and those addresses might look something like that. So this may seem a bit obscure, but it's important for things that we're going to talk about later, that you think about an object as sitting in memory and then having references to other things sitting in memory that are connected to it. So it knows where its different properties and methods are. That is, primitives, objects, and functions that make it up. All right, so let's look at, in JavaScript, how we access those slots in memory, those properties and functions of an object. All right, so I have an empty app.js file, and I'm going to create our first object, var person, and I'm going to use the syntax equals, and instead of a primitive like a string or a number, I'm going to say new object. Now, let me be clear. There are better ways to do this, and we'll cover them shortly. But just for this moment, I'm going to use the new object syntax to create a new object because it's very obvious what's going on. So I'm creating a new object, and this is going to sit in memory. Now, I'm going to add properties and methods. So, for example, I can say person, and then I'm going to use what's called the computed member access operator. That's right, an operator. The operator is this, brackets. And inside those brackets, I put the name of the value that I'm trying to locate in memory. So let's say first name. It doesn't exist yet, so when I use the equals, Tony, it's going to create that spot in memory and give it that name, And this object will get a reference to the address of that location in memory. So it will know where first name is in memory. And that's going to be a primitive, a string. So it's called a property, the first name property. So this is one way to set and access properties. If I go back to my PDF of JavaScript operator precedence, you'll see that we have computed member access. It's very near the top, and it's left to right associativity, and it's brackets there. So this is an operator. What the operator does is it takes this object and this property or method name, and it looks for this on this object. It actually can do quite a bit more than that, but we'll see that much later in the course. But for starters, this is one way using a string to access this. So let me set a last name. Now, the neat thing about this operator is that I could set a string, let's say first name, and I can then use that string to access that property using that bracket notation or that operator. So let me first of all just log the person itself so you can see it, and then I'll log person. I'll use this bracket operator, and I'll pass this string, this variable that contains this string. And remember, this operator will take this object and look for a property with this name. So this name is first name, so it should find it. And what should it output? Tony. So let's go ahead and run this in the browser. And then I'll open my console, and there I see Tony. So the computed member access operator, those brackets, worked. They looked at the object as one parameter and that string as the other parameter, and went out and found that property on that object and gave me the value. Notice I also just outputted the object itself, and I can see those two properties, first name and last name. There's another property, this underscore, underscore, proto, underscore, underscore. Don't worry about that right now, but we are going to get into that later in the course. For now, we'll just focus on these that I've made, first name and last name. And I've outputted the first name using that special operator with the brackets. So let's go back to our code, and let's talk about another operator, the more common operator and clearer and easier to type operator for accessing properties and methods. Now this approach here that we just talked about, you will see sometimes in frameworks and libraries, because you can dynamically decide what property you're trying to get. You can base it off a string. But it's much clearer and easier to type the next one. All right, I'm going to console.log the first name again, but I'm going to use a different operator, the dot operator. And it is just what it sounds like, dot. Then I can say first name. The dot is an operator, it's a function. And when used after an object like that, well, if I go back to my JavaScript operator precedence PDF, you'll see it's just second from the top, right after the parentheses for grouping. It's left to right, and it's just a dot. And it takes two parameters, the object that you're looking at and the name of the property. Notice I don't have to put this in quotes or something, although that's essentially what it's doing. It's taking the object and passing the string that represents the name of the value that you're looking for. But I don't have to do that. That's not really accurate. You can't do that. It will simply, the syntax parser will understand that after you put the dot, what you've actually typed will be the string that's given to the dot. So that's just a lot faster to type. Person dot first name. And if I run this, since I'm already outputting the person and first name again, I'll just get the first name again. So I refresh, and there it is. See that? So the dot operator acted exactly the same as the brackets operator here. This is computed member access, and this is just called member access, the member access operator. Members being members of the object, right? Your fingers and your toes are members of your body. So these are looking for members of the object, the pieces, the methods, and the properties. So this went out and found this property because it's just a string. It's not called a method, it's called a property. Okay, so I could console.log person.lastname. Very readable, very easy to type, and that's what's really happening. It went out and found that memory location, that reference by name that's connected to that object. And I could have set this value as well the same way. In fact, remember that the other type of property you can have as opposed to a primitive is also another object. So I can attach another set of names and values. Let's say that person.address. I'm going to make that, instead of a string or a number or a Boolean, I'll just make it another new object. So it's an object sitting inside an object. And then I can use the dot operator, for example, and add properties to my sub-object, my child object inside of here. Now remember, these are operators, so how do we know which one gets run first? Well, we go back and we see that the associativity of the member access operator is left to right. It has left associativity, meaning that the leftmost dot will get run first, get called first, because they're functions, and then moving on to the right. So this one, between person and address, gets called first, so it says, okay, I'll look at the person object and look for a property or a method that has that name. And then it finds that in memory, and then this second dot operator is called, and it says, okay, on that thing, on that object that I just found in memory, I'll look for a property or a method on that called street. Now in this case, it won't find it, but I'm setting a value, so it will create it and give it that initial value. And I could just keep doing this. So I might have address.city, let's say New York, and state, let's say New York. And you can see I could make this other sub-objects and sub-objects and sub-objects, and I could just keep going because it's a left to right dot operator, left associative, and the objects can keep containing other objects, which can contain other objects, which can contain other objects. So this is very powerful. And realize that the objects themselves and their properties and their methods are all just sitting in memory. These dots and these brackets, passing strings to them, they're just functions. They're just operators, a way to access that information. So now I have this object sitting in memory. I could do a person.address.street and output that, and it'll go find it in memory running those two different operators. I could go person.address.city, and it will find that. And I could, on the same object, just use a different operator. So I could go address using the computed. This is also left to right. If I look, it's left to right. So I can also then just do another one. Let's say state. This is essentially doing the same thing. It looks at the object, finds a property or method called that, runs this operator first, then the second operator, it'll look for a state property on that. And the dot is doing the same thing. And they're both simply accessing the same memory locations via the same names. So they're just two different functions that are essentially doing the same thing, and I refresh, and there I'm outputting my values that are sitting in memory using both operators. So again, objects are name-value pairs sitting in memory. They can contain other name-value pairs, that is, other objects. They can contain other properties, strings, booleans. They can contain numbers. They can also contain functions, which are called methods. But we're not going to quite get there yet because there's a couple other things we need to understand. But good enough for here. Remember that this is not the preferred way to create a new object. We'll get to that in just a second. And also remember that although we can use the dot or we can use the computed, the bracket notation here for finding properties and methods, The preferred approach is just using the dot operator. It's very clean, it's very clear, and it's also easier to debug and find problems. So I always recommend that you use the dot operator unless you really need to access a property or properties using some kind of dynamic string, some kind of string that can be changed, that you can look at programmatically. But to start with, always use the dot operator. That's objects in the dot.